Wait.
It's actually terrifying.
It took me a good amount of time.
That's just going to make it more terrifying. Okay. So here's what we got. So today we're going to transition from like graphical addition of vectors into using trig functions. Okay. And then, so that's that assignment tonight. And then tomorrow we'll review, and then the test over velocity is going to be on Friday. Okay? So that's kind of where we're at with that. All right. So the reason that I make you go through and draw these out graphically first is that I found that it makes like the trig functions and that whole process make a lot more sense. Because there was one year, it was the spring, we'd had some snow days, and I skipped like doing the graphical stuff, and I went straight to the trigs, and it was an absolute, it was a train wreck, okay? So then I actually had to go back and teach them the graphical method, and then they go, oh, now the trig makes sense. So this is why I make you do the graphical side first, so that you have this visual of what's taking place. So let's say, for example, you have like number 5, okay? So I just want to make sure everybody's kind of cool with what I'm looking for. So number 5, you just got this sketch. I'm just going to make a sketch. You're actually going to draw this out. You're going to draw a line 5 centimeters long. So here's going to be vector A. Here's going to be vector B. Here's going to be vector C. And then you're going to draw that resultant. Okay? So when I look at this, when you're doing these diagrams, I beg of you, keep them separate, keep them labeled so I know what is what. Don't let these like cross over and merge into one big, like ink blot test. I've got to stare at it and go, wow, it's a spider web, cool. No, okay? Keep them separate. You don't necessarily have to write out the values for A, B, and C, but at least label the vectors, okay? Put arrowheads on them. That's the whole point, because you're showing the direction of these values, which direction they're going. So even just on a crude sketch, okay, just a crude sketch, I know that this angle is going to be somewhere between 0 and 90 degrees, okay? Somewhere in that range, right? Just based upon a sketch. And then you're going to actually measure that length. So like on number 6, excuse me, on number 5, this is number 5. So number 5, that magnitude should be around 7 centimeters, and your angles should be like in the 60s, okay? Let's get into the ballpark of what you have going. Now, what you should see on 7, 8, and 9, all of those magnitudes should be around 4 centimeters, okay? They should all be around 4 centimeters on those resultants. And all of those angles, and this is a huge ish, okay? This is huge ish. But your angles on 7, 8, and 9 should be around 170 degrees. Okay? That's an ish. Now, if you have 200, that's way outside the ish. Okay? That's like ish and a skosh. Okay? So all of those angles should be around 170. Now, let's talk about number 11 with Bob. Okay? So on number 11, here's the action that you got going. So this is a situation where you want to set up a scale. So, because this is like 3.8 kilometers. 3.8 kilometers is about 2 miles. I don't want you to draw a vector 2 miles long, okay? Be a lot of paper. So what you could do in a situation like on number 11, you could say, hey, I'm going to let 1 centimeter equal a kilometer. Okay? It's a nice scale. It's a 1-to-1 deal. So here's the setup on number 11. So he's going to take off 3.8 at 45 degrees, or something like this. And then he's going to turn and go 5 kilometers at 270. Okay? And then he's going to have 6.5 at 225. Now remember, when you do that 225 degrees, that has to be measured from this positive x-axis. So imagine that you're here and this diagram becomes a whole new system of measurement. So when you're doing that 225, here's 180. So 180 is going to get you around to here. Basically, then you're gonna add 45 degrees to it, and so that's gonna give you that 225. So this is gonna be coming down something like this. So this is just kind of a crude sketch of what this should look like. Now, I wanna point out the differences of what I'm looking for on that last question on number 11. So it says, how far and in what direction should Bob travel if he's returned to base camp Alpha? So here's the difference. If you're Bob, Bob is starting here, and Bob is going to go in this direction, okay? So if you're Bob and you're telling Bob where to go, this angle is going to be measured from this positive x-axis around like this. So just again, just as a crude sketch, if you're Bob and you're heading back, his angle has to be less than 90 degrees, okay? Just a crude sketch. His angle has to be less than 90 degrees, okay? So when you have your angle, if you're not somewhere between 0 and 90 degrees on that question about the direction that he's going to take, that's what you got. Now, in contrast to that, if you're the search party, okay, and here's the difference. So if you're the search party, let me draw that in a different color. Here's the difference. The search party is going to start at the base camp and head out to here. So if you're the search party, your angle is going to be start here at positive, going to be more than 180 but less than 270. So if you're the search party, and here's the difference. The search party is starting here, going down like this. That angle is going to be more than 180. But if you're Bob and you're headed back to the base camp, that angle is going to be less than 90. Okay? Because they're fundamentally going in opposite directions. So on that last question, I said, what's the relationship between the direction and magnitude of the search parties and Bob's? Whatever you do, just don't tell me, oh, their angles are different. Oh, for the love of it. No, okay? They're different. This isn't some political campaign, or the angle changes, all right? No. You can actually give the numeric value, you can use a specific word to describe it, but just do not say the angles are different. No, stop. More words in the English language than any other language in the world to describe things. Don't use different, okay? One of these, like for example, on number 6, 6 just has no resultant, okay? There's nothing there. You went out 5 centimeters, you came back 5 centimeters, okay?
So do we put 0?
Yeah, it's just 0.
Oh. Is it like 0 at 0 degrees or just 0?
Zero. There's no angle to it. There's just nothing there.
Okay.
It's like I have no money in my
Because
bank
it's a
account.
point,
How much do
right?
you have? 0.
Yeah.
Not at 0 at 5. No, 0. Okay. Anything at all, sketches are good. Anything you want me to go over? So good. Yes?
How do you grade them? Like, do you grade them to be with?
What do you mean?
Because,
Like how picky am I?
yeah.
I generally give you, I know what it should be. So if you're within a degree or 2, you're okay. Okay? And same thing with length. Like if it should be like 7.0 and you're at 7.2, I'm okay with that. Now if you're at 8, that's an issue. So yeah, I know that there's I give you some leeway. And that's the disadvantage of drawing it out graphically.
That's fine.
Okay. Now, do not hand this in just yet. Okay? You are going to hand it in today, but we need this to transition into trig functions. All right? So don't hand it in quite yet. You will hand it in today, just not right now. Okay? So stop that. I'm going to hand out the next assignment. I'm going to do a couple of these to kind of go in this transition. So basically, if you look at where we're at right now, so what you all have so far is that, like if you look at vector A, Here's how you guys drew this thing yesterday. You drew a line 5 centimeters long at 0 degrees. Okay? What was this? So, one option to get from the origin out to this point is to say you walk 5 centimeters at 0 degrees. Okay, that's an option. Okay, that's one way to describe how you get to that point. You say 5 centimeters at 0 degrees. The other way that you can get to that point, if you think about it, is an x and y coordinate system. So initially, it's pretty straightforward. So the other way that I can describe that exact same point is to give an x and y coordinate system. Oh, what's my x component? Oh, that's 5 centimeters. What's my y component? 0. Okay, so there's two ways. Let's say that I need dime to get from the origin out to this point. I can either say, hey, you walk 5 centimeters at 0 degrees, or you go to a designated spot on an x and y coordinate system that says 5 and 0. Okay? Either way, he's going to get to the same point. Okay? It's just how I tell him to get there. Now, when you deal with B, okay? B is 3 centimeters at oh, did that one wrong.
Should we write this down?
No, you're fine.
Okay.
Well, you will eventually.
On the yellow paper?
Yep.
So
hold on. So B is 3 centimeters at 0 degrees. Okay? So the other way that I can get to this point is to say, oh, you can go to the coordinate system 0 and 3 centimeters. Okay? That's it. So I've got no motion in the y, in the x direction. It's all in the y. Okay? Cool with this. So on this one, on your yellow sheet, where it has vector A 5 centimeters at 0 degrees, all I want you to do is say, oh, here's my x and y components. So on vector A 5 centimeters at 0 degrees, your x component is just 5. Oh, that's it. You're just going to go out 5. And then when you get to that, then you're not going to go anywhere in the y direction. So on vector A, 5 centimeters at 0, your x component is 5 centimeters. Your y component is 0. Now for vector B, your x component is going to be 0, but your y component is going to be positive 3. Okay? Now, C is a little sketchy, literally. So on C, this is, and I'm not going to make you do 2 of these, okay, because you're going to see the pattern after 2 of them, okay? So on another sheet of paper, I want you to take your protractor, and I want you to measure out and draw vector C just like you did, okay? So here's going to be vector C. I want you to draw that, and then I want you to measure the x.
You're so sweet.
That's everybody goes.
thank you, Ella. Boy, I just had it.
You said like on a piece of
It was
paper.
just like this that started. Okay? So, here's what I want you to do. I want you to do this for there's only 2 of them that I want you to do because you're going to see this, and that's why we're not going to do a whole lot of them. So, you're going to measure around 120 degrees, and you're going to draw vector C. Now, this is what's known as deconstructing the vector, okay, which sounds pretty nerdy. It's like, oh, we're deconstructing the vector, okay? So, when you deconstruct the vector, basically you're doing the reverse of what you did yesterday, okay? So yesterday, I gave you the x and y components, and then you drew the resultant, and you measured that angle. This one, we're reversing the process. I'm basically giving you the resultant, and you're finding the x and y components to get to that point. Okay? Now, because we're in the second quadrant, math nerds, pay attention. You're in the second quadrant, so what's going to be the sign of my x component? Negative. What's going to be the sign of my y component? Positive. So here's what I want you to do. Right quick, I want you to draw vector C. I want you to draw that and then measure how far over you go in the x and how far up you go in the y. And then I want you to do the same thing with vector D. Okay? I want you to come in here and go, okay, hey, vector D, that's 250 degrees. You're gonna draw this, and then you're gonna find out what the x component and the y component is. Now, with this one, you're in the third quadrant. So what do you know about the sign of your x component? Y component? So you're gonna have two negative components. So get that done right quick. That was loud.
Oh dear. No, I didn't.
What'd you get? I got
Did you get 3.4 or 3.5?
I got 3.5.
I have 3.4.
I got negative 2.1. 1.5. 2.1.
Okay. So, what did somebody get for your x component on C?
Negative
2.
Negative 2, exactly?
Yes.
So something around negative 2. Okay? What do you have for your y component?
3.5.
Positive or negative?
Positive.
Positive 3.5. Now, here's what I want you to look at how we're making this door swing. Okay? So, yesterday, at this point, everybody's back, right? Okay, now we can shut off the camera. I'll send you, Taylor, I'll send you guys at the beginning of the lecture. Okay,